Okay, it is time to discuss trigonometry. So these are our content standards and the math practices we'll be using on our assignment. So previously you've used the Pythagorean theorem to find missing links in right triangles, and now we're going to find trigonometric ratios using right triangles, and we're going to use trigonometric ratios to find angle measures in right triangles. We've got quite a bit of new vocabulary: trigonometry, trigonometric ratio, sine, cosine, tangent, inverse sine, inverse cosine, inverse tangent. And these are the key, most important, mostly used trigonometric ratios. So you probably want to put these in your notes somewhere. The word trigonometry comes from two Greek terms, trigon meaning triangle and metron meaning measure. So the study of trigonometry involves triangle measurement. A trigonometric ratio is a ratio of the lengths of two sides of a right triangle. So we're going to use these. I hope you've paused the video for a moment and write these in here. So what sine of A, so draw your figure, your capital letters and your little letters, and this is the very important part. We're going to be using this. So if you haven't got that written down, pause for a moment and get it in your notes, and then continue on. So first of all, we're going to express sine, and even though it looks like sin, it's pronounced sine. We're going to express sine of L as a fraction and as a decimal. So from your notes previously, you know that sine is the opposite over the hypotenuse. So the leg that's opposite L is 12, and the hypotenuse is 37. So we're going to rewrite that as 12 over 37. In your calculator, if you put 12 divided by 37, you're going to get 32 hundredths. So in this assignment, we're asking for both of these answers. Now we're going to look for the cosine of L. Now cosine is the adjacent over the hypotenuse. So adjacent over hypotenuse. 35 over 37, which comes out to be 95 hundredths. Now let's look for the tangent of L. The tangent is opposite over adjacent. 12 over 35, so that's 34 hundredths. Now we found everything. We found sine, cosine, and tangent for L. Now let's find it for N. Sine of N. Sine is opposite over hypotenuse. 35 over 37. Cosine of N is adjacent over hypotenuse. And then finally we're going to find the tangent of N, and it is the opposite over adjacent. So that was fairly simple, wasn't it? It's just remembering the difference between what makes up sine, cosine, and tangent. So we will work on some little exercises in class how to remember which ratio goes with which trigonometric term. All right, time to check your progress, and we have several here, so pause for a moment, find sine of A, and then come back and check your answer. Sine is opposite over a hypotenuse, 12 over 20, which reduces to 3/5. I'm sorry, simplifies to 3/5. Find cosine of A. Cosine is adjacent over hypotenuse, so 16 over 20 simplifies to 4/5. Tangent of A. Tangent is opposite over adjacent, which is 12 over 16, which simplifies to 3/4. Find sine of B. Sine is opposite over hypotenuse, which is 16 over 20, so 4/5. Cosine of B. Cosine is adjacent over hypotenuse, which is 12 over 20, which simplifies to 3/5. tangent of B? Tangent is opposite over adjacent, which is 16 over 12, which simplifies to 4/3. Excellent job. Special right triangles can be used to find the sine, cosine, and tangent of a 30, 60, 90, and 45-degree angles. So we're going to use a special right triangle to express the cosine of 60 degrees as a fraction and as a decimal to the nearest hundredth. So first of all, we need to draw and label our right triangle. Very good. So the short side opposite the 30 is x. We've got a 30, 60, 90. So we know the long side is the short side times square root of 3, and the hypotenuse is 2 times x. We learned that in our last lesson. Cosine is adjacent over hypotenuse, which is x over 2x. So the x's simplify, they cancel out, so we got 1/2. 1 divided by 2 is 0.50. So 5/10. So time for you to check your progress. So read through the problem, work it through, then come back and check your answer. Okay, we know that tangent is opposite over adjacent, and that's going to be x square root of 3 over x. The x's cancel out. We end up with a square root of 3 or 1.73. Okay, time to use a real-world example to estimate measures. Fitness trainer sets the incline on a treadmill to 7 degrees. The walking surface is 5 feet long. Approximately how many inches did the trainer raise the end of the treadmill from the floor? We're going to let y be the height of the treadmill from the floor, and the length of the treadmill is 5 feet. We're going to change that to inches. We'll work with the inches. So since we've got the opposite and the hypotenuse, we're going to find the sine of 7 degrees, which is opposite over hypotenuse. We're going to multiply both sides by 60. So 60 sine 7 is equal to y. Now we're going to use a calculator to find y. If you're using a graphing calculator, when you go into mode, you need to make sure that you change it from radians to degrees, because we're talking about angle degree measures. When you do that, then your keystrokes are simply going to be 60 sine 7 enter. 60 sine 7 enter. You'll find the sine key on your calculator there, usually just above the numbers. So the treadmill is about 7 3/10 inches high. So let's check our progress. Using the same kind of process that we used in the example before, let's find out how high does this ramp raise off the ground to the nearest inch. So pause for a moment and work the problem, and then come back and check your answer. Well, from 4.8 degrees, we are given the adjacent side and we're asked to find the opposite. So opposite and adjacent, we're talking about tangent. So the tangent of 4.8 is the opposite over adjacent, or x over 15. Now 15, if we change that to inches, is going to be x over 180. So that's going to change things quite a bit. So when we divide both sides, or multiply both sides by 180, in our calculator we're going to enter 180 tangent 4.8. We're going to come up with 15.1 inches. So 15 inches is our answer. Now we're going to use inverse trigonometric ratios. So in example 2, we found out that cosine of 60 degrees was about 0.50, or about 5/10. Now it follows that if the cosine of an acute angle is 5/10, then the angle measure is about 60. So we're going to read this as inverse sine of x, inverse cosine of x, inverse tangent of x. So in other words, we have the measure and we're trying to find out what the degrees are. If you know the sine, cosine, or tangent of an acute angle, you can use a calculator to find the measure of an angle, which is the inverse of the trigonometric ratio. So let's find angle measures using inverse trigonometric ratios. We're going to use a calculator to find the measure of angle P to the nearest tenth. So the measures that are given are the leg that's adjacent to the angle P and the hypotenuse. So we've got adjacent hypotenuse, which is cosine. So inverse cosine, when we're given the measurements of the legs, we can inverse cosine 13 divided by 9. So these are our keystrokes. We hit the second key on our calculator and the cosine, which gives us inverse cosine. And the parentheses that they give us, we're going to enter 13 divided by 9 and enter. So we're going to get right about 46.8 degrees. All right, time to check your progress. So we're going to use a calculator to find the measure of angle D to the nearest tenth. What are we given from D? Opposite hypotenuse. So what would that be? So pause and work that one out, then come back and check. So we're going to use the inverse sine of D with the opposite over the hypotenuse, and we get 44 1/10. Now, when you use given measures to find the unknown angle and side measures of a right triangle, this is known as solving a right triangle. To solve a right triangle, you need to know either the two sides of the side lengths, or you need to know one side length and the measure of one acute angle. So on this one, we're given the opposite and adjacent. We're given two side lengths, so we're going to use tangents. The tangent inverse of 4/7 will give us the measurement of angle A. Using the calculator, if we put second tangent 4 divided by 7 and enter, we get about 30 degrees. So since the measure of angle M, we're going to use complementary angle. We've got the 30, we've got the 90. So we can say that the measurement of angle B is approximately equal to 60. So the measure of angle B is about 60 degrees. Now we can use the Pythagorean theorem to find that side length. So AB is approximately 8.06 or 8 6/100. So the measurement of A is approximately 30, measurement of B approximately 60, and the segment AB is approximately 8 6/100. Okay, time for you to check your progress on a similar type of problem. So we've got a right triangle. We're given two sides, just like that last problem, and we're to find the round the side measures to the nearest tenth and angle measures to the nearest degree. So find the measurement of angle A and angle B, and tell me what the measure of side AB is. Okay, very good. We're given the tangent of B. To find B, I'm taking the tangent of B because I've got opposite and adjacent. So the inverse tangent of 8 divided by 11 is 36. That means 90 minus 36 is 54. 8 squared plus 11 squared is equal to our segment AB squared. So 185 is equal to C squared. Take the square root of both sides. C is equal to 13.6, or side AB is equal to 13.6. Very good. You're ready to begin the exercises.